Okay, we just did domain, so now we're going to talk about the range. Remember, range goes down and up. So actually our graph covers everything down and up except what? 0. So let's write it as an inequality. Now remember, range is y. So y is less than 0 or y is greater than 0. In set notation, braces y such that y is not equal to 0. In interval notation, where the symbol U means union from negative infinity up to 0 and from 0 up to positive infinity. Questions thus far? All right, page 471. Now what we're going to do is we're going to take that parent function and we're going to start transforming it. So if you have your cheat sheet from when we first did transformations, then you can use that. So we're going to add H's and K's and A's and B's. Okay? So we're going to fill in on page 471. We're going to go through this and just fill in the questions here. So we're going to take the regular graph and we're going to add an H to it. So what happens when I subtract 3 from X? Now think about the X. Remember, on the X, it's always going to be what? Opposite of what you think. Okay? So if I'm subtracting 3, where am I going?
Right.
Right. All right, so we're going, it's a translation. And the graph is going to the right. Circle right. Okay, what happens when I add 3 to X? Okay, it's a translation. And this time it's going left. 3 units. Now, that's nothing new. That's stuff we've done before. The only thing that's different is this time it's a fraction instead of just a regular X. Okay? All right, part B. Now we're going to add a K to it. Okay, remember K's at the end. So if I add 3, it's going to be a translation. And it's going to go where? Up. Remember, our K's are not opposites. Whatever it says is what it does. If you add 3, you're going up. What about subtracting 3?
Down.
Down. So it's a translation, and it's going to go 3 units down. Any questions on that? Same thing we've done in the past. All right, part C. Now we're going to add the A out front. Okay? The A out front is a what? Well, it's either going to be a stretch or compression, but is it vertical or horizontal? Vertical. We talked about out front. I always say V stands for Vernon, and Vernon's out front. So it is a vertical something. Vertical. It's a 2. So it is a stretch. It is a vertical stretch. Remember, if it's a number more than 1, it's a stretch. If it's less than 1, it's a compression. By a factor of what? 2. The graph G of X on the part B, it's 0.5 times 1 over X. It is a what? Vertical compression. By a factor of 0.5, or you could put 1/2 if you want. C is the same as B, except they added a negative on there. So the graph of g of x equals negative 0.51 over x is a, the negative doesn't change what it does. It's still a vertical compression by a factor of 0.5, as well as a what? Reflection, good, over the x-axis. Over the x-axis. And D, the graph of g of x equals negative 2 times 1 over x is a
Vertical stretch.
vertical stretch. By a factor of 2, as well as a reflection across the x-axis. Questions on that? All right, part D. Now we're adding the favorite B. Okay, not the A, but the B. Predict the effect of the parameter B on the graph g of x equals 1 over bx for each situation. The graph of g of x equals 1 over 0.5x is a what? Horizontal stretch. Okay, so it's 0.5, so you're thinking it's a fraction. So if it's 0.5, it's really 1/2, which is 1 over b. So b equals 2. So it's really a stretch. It's opposite of what it looks like by a factor of 2. The graph of g of x equals 1 over 2x is a horizontal compression. By a factor of 1/2. C, the graph of g of x equals 1 over negative 0.5x is a horizontal stretch by a factor of 2, as well as a reflection over the y-axis. The graph of g of x on D equals 1 over negative 2x is a what?
Horizontal compression.
Horizontal compression by a factor of 1/2, as well as a reflection across the y-axis. Any questions? Same thing we've done before.